Hi friends and students, good morning. And 12th Physics, 7th unit, second volume. The unit 7, a very important chapter, dual nature of radiation and matter. Dual nature of radiation and matter. Before going to say something about radiation and matter, what is meant by radiation, what is meant by matter, that's a thing that is we must clear. Matter is nothing but a material object. Matter is nothing but a material object which is considered a tiny concentration of a matter. It is known as particle. Particle is a material object which is considered a tiny concentration of matter. For example of this particle, marble balls, atoms, the grains of sand, proton, electron, and so on. And these bonded with one condition localizes space and time. Here we must clear one thing. All matter are said to be particle, but all particle are not said to be a matter. There's a very important concept that we are going to deal about in this chapter. The next one, wave. Generally, initially, the scientists suggested that corpuscular theory as well as wave theory. Later on, it may develop as a particle theory and wave theory. And the scientists also suggested that energy is radiated through the media in dual property. Energy was radiated in the media in dual property such as either wave or particle. Then some other scientists question why not for particle and matter. The things was developed so on. That's why this chapter arises here for us. Now, wave is a broad distribution of energy, but not localized with space and time. For example of wave, sea wave, ripples in a pond, sound wave and light waves, etc. But one interesting point here, both particle as well as wave have a property to carry energy and momentum from one place to another. That's a very important concept. Both particle as well as wave have a tendency to carry the energy and momentum from one place to another. But for traditional scientists, according to classical physics, they explain the motion of macroscopic objects treats particle and wave as separate components of physical reality. Both are separate. Particles and wave are separate according to motion of the macroscopic object. Likewise, the mechanics of particles and the mechanics of the optics of wave are traditionally independent to each other. It has its own experiments and principles. Now I want to explain this the same concept under the valuable examples electromagnetic radiation. The electromagnetic radiation, if they exhibit interference, diffraction, and polarization, then this electromagnetic radiation accept wave theory. Accept wave theory. In other words, if the electromagnetic radiation exhibit the light body radiation, black body radiation, photoelectric effect, under some other circumstances, then this electromagnetic radiation belongs to particle phenomena. Now I ask one question, only one question. How the electromagnetic radiation may sometimes explained as a wave, may sometimes explained as a particle phenomena. If the electromagnetic radiation exhibit interference, diffraction and polarization, then it is considered to be as a wave. If the electromagnetic radiation exhibit the black body radiation or photoelectric effect, then it considered to be as a particle phenomena. That's a very important concept. But after some years, scientists discovered electron, proton, and the charge of the electron, and the mass of the electron, charge of the proton, mass of the proton. And because of these properties, all scientists are accepted particle theory itself. Particle theory itself. But some other experiment later on, we accept these proton and electron also exhibit wave theory also. That's why at last we concluded that traditionally or as well classical mechanics or classical physics, particle of nature waves and wave nature of particles both have a dual nature. That's a very important concept. Here, particle nature of waves. The waves exhibit particle nature. Sometimes particle exhibits wave nature. So that we accepted the dual nature. That's a very important introduction for this chapter, and we are going to see what will be the experiment, what will be the principles, what will be the innovation that are discovered in this chapter one by one. Thank you.